So, hello everybody. While I know that hope is not a strategy, and this is what SREs are saying, so it's a mythical concept from SREs, we hoped that we would start the workshop in time, but apparently this was not possible, so we are sorry for that. As a short presentation, my name is Alexandra Varzaru, and I am the product owner for the SRE team at Metro Systems Romania. And this is André Duis. He's the domain owner at Metronome. What is Metro Systems? What is Metronome? Well, we are in fact the same company, and we are the software provider, the internal IT software provider for the Metro Group that is consisting of more than 25 countries' visibility. In Germany, we are called Metronome, and we have offices in Düsseldorf, in Berlin, and in Hanover. While in Romania, we are Metro Systems, and we have first started in Bucharest, then opened a branch in Brașov, and latest in Cluj. In Cluj, you might also know us as Tech and Trade, so we have come up with 3 different ideas for Cluj. There is first the Tech and Trade Lab, where is the offices where people that are employed in Metro Systems work, but there is also the club, which is an open space for the IT organization, and the hub that is special towards startups, where startups can come on, pitch ideas, get consultancy, and then in the end get some funding. Now that's about it, about our introduction, so let's just jump right in the topics because we know that we are a little bit late. So we're going to try to stick to the plan, but we're going to rush a little bit into it. Today, modern operations approaches for microservices architectures. It's all about microservices, so it's all about cloud native applications. We're going to tackle topics such as SRE, such as DevOps, knowledge workers, change management, error budgets, continuous deployment, continuous delivery, and so on and so forth. But before starting, I'm going to hand over to André because we have a small quiz for you. Hope you will enjoy it.
Yeah, and here we actually have the first technical challenge. I need to connect to the internet, which I was hoping to do before.
So the quiz is going to be done via the internet, so we are checking if we have right internet connection. What I would ask you to do in the meanwhile is take out your phones and open kahoot.it. It's a quiz about continuous delivery, about SRE, DevOps, and modern operations approaches that, in the end, has some prizes.
So if you've does it work? Yeah. So if you have opened the kahoot.it app, you just need to enter the PIN, and then you can register. Give yourself a name. We will have some prizes afterwards, so it would be good to find you after finishing the quiz.
So apparently we already have a winner.
So already winner? Yeah. So in the quiz, it is important that you answer fast and correct, because Also, how fast you answer it is going to end up or be calculated into your scoring. Anybody still has problems signing in? Or can we go ahead? Okay. Then we start. So get ready. What does the abbreviation SRE stand for? Stop Risk Everything, Short Response Emergency, Support Response Entity, Site Reliability Engineering. Okay, it was Site Reliability Engineering. Next one. Radu is on first place. What does the abbreviation CLAMS stand for? Cloud Learn Application Monitoring Security, type of muscles, culture, lean, automation, measure, sharing. So it is culture, lean, automation, measure, sharing. Oops. And the next one. What does the abbreviation SLO stand for? Support Liability Objective, Service Level Objective. So that one was better. And next, what is a canary deployment? Deploying a specific commit to production, trying new functionality with a subset of users. Okay, well done. Trying new functionality with a subset of users was correct. Who or what is Borg? Alien who invented the internet, Google's internal container orchestration platform. So it's not the alien, you're right. It's Google's internal container orchestration platform. What is gRPC? A testing framework, open source monitoring tool, efficient over-the-wire communication protocol, or Google Cloud product. So it is an efficient over-the-wire communication protocol from Google. Next. What describes continuous deployment best? Every commit can be deployed to production. Every commit is deployed to production. So it's the second. Which is an CI/CD n-type pattern? TDD, long-lived branches, trunk-based development, or feature toggles? So it is long-lived branches. What are the 4 golden signals? Latency, traffic, errors, saturation, load, availability, defects, lines of code. It is the first: latency, traffic, errors, and saturation. Oh, we have a new first. What does the abbreviation MTBF stand for? Master track boot format, mean time between failure, malicious trace being found, maximize team between failure. So you're right, it's mean time between failure. What does the abbreviation MTTR stand for? Minimum time to recovery, mean time to recovery, moment of time to run. Mean time to recovery is correct. What is an error budget? A way to balance velocity and stability efforts, reducing a product owner's salary based on the amount of errors. So it is the first one. Actually, some people like it to be the second one, but... What describes continuous delivery best? Before it was continuous deployment, remember? Every commit is deployed to production. Every commit can be deployed to production. Every commit can be deployed to production. Okay. What does the abbreviation ELK stand for? Animal within the deer family, Elastic, Logstash, Kibana. Correct. It's not the deer. What is toil? Oops. Repetitive manual work that can be automated, a fee collected by local authorities. Oh, what is going on? What does RAM stand for? Real user monitoring, real user misusage of application, risk usability measurement, alcoholic beverage. So it's real user monitoring, it's not the beverage. And that's it, we have a winner. Bogdan T. Who is Bogdan T? Wait a second, I get your prize. So this is your prize, the Site Reliability Engineering book. How do you know all of this?
I already read the book.
Then you might want to give it to somebody else.
Yeah, sure. Cool. Thank you.
Thanks. And who is second? Adi B. Who is Adi B? Were you cheating? No. So you get the book, release it.
Thank you.
How do you know all of that?
We work with this stuff all day long. We work with this all day long.
Okay. That's good. So when we later have some questions, we will ask you. And number 3. Rat A. Who's that? That's you. So for you, we have the Phoenix project, the book. How do you know all of this?
I work for a while with DevOps industry. Okay, thank you very much.
Okay, it's good to know you guys. Then we don't have to do so much work anymore
congrats.
here. And congrats, everybody. So later on, pick these guys and ask them questions. They are the experts. So. Okay, coming back to the presentation. Something that people constantly ask or wonder about, what is the difference between SRE and DevOps? And finally, DevOps has been invented as a culture because in the past, developers and operations people have been kind of working against each other because developers did not run the application in production, and they threw it over the wall to the operations people. That was creating all kinds of problems and tension between those two groups, and DevOps is a culture to improve that situation. And the same ideology is shared within SRE, and SRE finally implements a DevOps culture, so it is a bit more strict. And what SREs do is they focus on the question, how would I design a system if nobody would be on call for that system? And also they are balancing the risk of applications, so they try to make applications as available as they need to be. So it's very descriptive, and Alexandra will later explain you more detailed how our team is doing SRE. But before you do SRE, we want to talk about cloud infrastructure, because SRE can only be really powerful if you do cloud infrastructure, and for cloud infrastructure you can have different models to introduce it into your organization. The first model you see here is the platform team. So the platform team abstracts away the cloud infrastructure of your team and provides application teams with infrastructure from cloud providers. They can abstract away different cloud providers, so you have the possibility or the benefit of flexibility, and you can change cloud providers. Also, if you don't have a lot of DevOps know-how in your teams, you can start with that approach because you can centralize that knowledge in one team. Also, if you are in a hybrid cloud scenario, this probably makes sense. And your development teams can focus completely on the development of new products. So this is a good model to start. Then there are different models like the fully autonomous model, where teams completely autonomously implement different cloud providers. But then you have the challenges that you have to do your billing, your self-security, and so on. It's all going to be very difficult. But you have the flexibility, and you can use as many products as possible. You can use the right managed products for your solution, and you don't have to implement them in a generic way. But you need a very high DevOps maturity. And the third model is basically a decentralized kind of platform model, but already with internally open sourced blueprints that teams can reuse, and that is being built by a cloud foundation team. So the cloud foundation team provides the blueprints. They make sure that the accounts are being set up for the Google for clouds, and they help teams to implement the infrastructure. So what we did in our company is that we started with a platform model. So the platform model, we started with a lot of teams starting to move into the cloud, and then we started abstracting away the entire infrastructure. We also started with a cloud provider that we thought initially was a good choice. Meanwhile, we know it is not it doesn't have the size that we need. And then we moved to Google. So we moved from Rackspace to Google, and only because we had this central platform team, it was possible so that we were able to do that. But we also learned, in this scenario, our teams don't have the right flexibility and freedom to try out cloud infrastructure. So we're starting to migrate into another scenario. It's kind of a hybrid scenario between platform and cloud foundation. On the right, you see full freedom for development teams. They get blueprints, they get account security, they get all the things that don't necessarily contribute to a better product, but they are free to use all managed cloud products they want to use. And on the left, we still have this platform approach, and we can help teams in a very generic way. And this scales very well. So a few tips. When you start with implementing cloud infrastructure, start already to internally open source your provisioning configuration code, because developers also need to have the visibility into how the infrastructure is provisioned. Share logging and monitoring between application and infrastructure. because here you need to have all the details, the full picture of your infrastructure and your application to debug problems. If developers don't see their logs and the monitoring of the infrastructure is very hard. Start doing product management even in platform teams. So it is very easy if you do the platform approach that the platform team goes back into good old operations mode, and then people have to wait very long for changes, and developers are not seen as users. And be careful with abstractions. So we did the mistake that we abstracted away Docker. Developers didn't have to bother with Docker, so the knowledge around Docker was not very high, and we had our own proprietary solution, which finally we had to get rid of. And last but not least, start measuring the uptime of your own products or your own platform, and measuring service level objectives, which is Alexandra's topic.
Yeah, thank you. So, why do we need SLIs, SLOs, error budgets? Because failure is inevitable. You need to get good at tackling it rather than trying to avoid it and concentrating in learning from it. A little bit of terminology. SLIs, what are SLIs? The SLIs are service level indicators that are seen from the user's perspective. A tip here, you can use the forgotten signals from Google, which, as you've already answered, are traffic, saturation, latency, and error rate. You can also define other SLIs. There are some good SLIs, but there are also some quite bad SLIs. So I wouldn't really define an SLI based on CPU or memory, because they really aren't good indicators of how your users are feeling in the end. SLOs are service level objectives. They are a combination of different SLIs. It's how reliable do I want my application to be in the end. And SLAs, which I think we already know already, is service level agreements. Is the contract that you sign together with your consumers for the entire application. The main difference between SLAs and SLOs is that typically SLAs are based on the whole application, and typically they are just the time, like we have 99.9% availability targeted for our application, while SLOs are a little bit more complex, as they can include time availability, but they also can include error rate or response time or latency. And in the end, based on SLIs and SLOs, you define the error budget. In order to explain it easier, it's pointing to the computer. But the computer is frozen. In order to explain it easier, well, an error budget can be 1 minus the availability, which basically means that if you have 3/9 of availability, then you would in the end up for a 30-day allowed downtime or taking risk within the application of 43.2 minutes. The higher you go, the more strict your error budget would be. Error budgets are being used a lot between the development teams and the SREs in order to mitigate and to know how reliable your application is. They are also used by the product owners in order to mitigate risk within feature development. How do we do that? Well, as a matter of fact, SRE's job is not zero outages, as there is no 100% availability. Instead, we measure the error budget and have a policy around it. While measuring the error budget, it's best to look at just the critical points within your user journey map. So as taking 2 examples, one of them would be you write an email. So you go to your computer and start writing the email. When do you consider that the email is being sent, that you have finished your job? When you press the send button, when you see that the email goes out of the drafts folder, or when you get a confirmation from the from the receiver of the email that it has been received. Most of the people consider that the email is being sent when the send button is pressed. Therefore, there might be a higher SLO, a tougher SLO on the send button rather than the exchange server behind that email client. Another example where availability is not really that critical is an ATM. You have your card and you want to extract some money, so you go to an ATM. The ATM is not running. The ATM is out of service. You don't get that frustrated. I mean, it's a little bit of frustration, but you can always find another ATM nearby in order to cash out the money. When you would get, or at least I would get really frustrated, is if I go to the ATM, I enter the card, I enter my PIN number, and then I press extract also the 100 lei. The ATM doesn't give me the money, but it extracts from my bank balance. Thus, right then, I would need to have a tougher SLO and a tougher error budget on the process of extracting the money, of checking if the money has been received by the credit owner. While SLOs and error budgets sound easy and nice, you also need to have a policy around it in order to have SREs work properly with the error budgets. Thus, what we have defined within our team is, if the error budget is endangered, so if from 43 minutes we reach about 40 minutes, we inform the development team that they need to stop feature development and focus on reliability. What we also have as options is we keep a rainy day fund, which is mainly used if there are issues that erode the error budget, but are not specific to the development team itself. It may be that the availability zone went down. It may be that we have flappy behavior inside the application. And in the end, of course, we also need to have a nuclear option, which is SREs decide to support another product, so they give back the on-call to the development team, as sometimes feature development is really more important than reliability. This is really important. It's really important to have a policy around error budgets and to use it, as in the end, SREs need to have the authority to stop feature development. And as in the end, the first principle for SRE is that the most important aspect from a user's perspective of the application is its reliability. No matter if you have a website that is full of really nice pictures and of really nice content, if it's available just 50% of the time, the users won't like it. So we've talked about reliability. I will step in a little bit on how to define your first site reliability engineering team. So, based on the Oxford Dictionary, reliability means the quality of being trustworthy or of performing consistently well. And that's what we are trying to do with site reliability engineering. We started with it with one question or one remark. If I have to wait for a human to detect an error, I'm already lost. So this set the pace on how to begin with site reliability engineering. We don't want humans to detect the errors. We want them to be detected automatically, and in the end, ideally, to be resolved also automatically. So keeping the on-call duty with no needing the on-call duty anymore. We started up with reading some site reliability engineering books, such as the Site Reliability Engineering book, plus the newly launched Site Reliability Engineering workbook from Google. They are also available to be read via the link above. We also took a look at Seeking SRE. Seeking SRE is written by a guy that used to be an SRE for many years at Google and then moved to another company. It provides insights on how to start up the SRE team and how to scale it. And of course, we also took a look at production-ready microservices, because we focus on SRE just on services that are cloud native and that are built on a microservices architecture. Production-ready microservices written by Susan Fowler. Susan Fowler is or used to be, I haven't checked in the past month, an SRE at Uber. Then, having everything in mind and having our plan set, we have decided to start with a generic SRE team that should be impactful, strategic, and should work on projects that would later provide a framework for empowering the development teams. So basically make the developers' teams' lives much easier in terms of stability, availability, and reliability. So, next step was, of course, to convince the executives that we need site reliability engineering, because it was going to be also a culture change within the organization. In order to do that, we defined responsibilities and we made a business case for it. After defining the responsibilities, when defining the responsibilities, we thought of SREs having four hats in the end. So they are first investigators, they take over the on-call, and they resolve the issues that appear in production. They are then consultants. They consult the development teams in terms of best practices, anti-patterns of microservices architecture, or in terms of performance, availability, reliability, stability, etc. We also consult teams that we don't work directly with. They are also analysts, so they work a lot with observability and not just monitoring and alerting. Well, once we had the responsibilities set, we went to recruiting the first people. We look within our company and saw that we have potential already, of course, within the company. So we recruited 3 beginning SREs. Together with them, we started to define our way of working. So we are currently a product team that delivers several small products, but also delivers consultancy and on-call duty to different teams. And we decided that we were going to work in Scrum and that we were going to have those some basic rules of working. We also defined an onboarding process for the applications that we were going to provide SRE for. Onboarding process that started with a reliability checklist that consisted of anti-patterns and best practices and questions for the platform teams or for the development languages themselves of the applications, or for the agile process if they follow it or not. After that, we took a look at who can be our first pilot. Are we going to choose an application that is small? Are we going to choose an application that is entry level in terms of development, or are we going to choose an application that is already mature? We went to choosing as a pilot an application that was already mature and quite critical to the application. That's because we wanted to have a quick buy-in and a fast acceptance rate of the SRE team. So we chose the identity and access management, which is one of the few applications that require an SLO of 4 to 5 nines within the company. We discussed with the product owner of that application, and we have set up the onboarding phase from the reliability checklist being completed to having them present us a high architecture map of the services that they have, and to defining monitoring, alerting, and so on. So we had them into SRE and we started the on-call duty for them. Then I had a tough job. I had to market my team and the concepts within the organization in order that so that the entire company knows what SLOs are for, what's the benefit of having error budgets, and so on and so forth. We did that by organizing workshops within the company. We currently organize an SLO workshop that helps the team define their first SLOs. We have scheduled some SRE open days where our colleagues can come by and see what we are working at. We have written articles, lots of articles on different platforms about reliability topics and best practices and anti-patterns. And we have had free discussions with other teams, either with product owners or with developers. And also we did presentations. Our company is great because we have the possibility to have internal presentations such as internal conferences, so we hijacked them several times with reliability topics. So you need to get your product known within the organization. As a special task, we introduced SLIs, SLOs, and error budgets into the organization's terminology and culture. Apart from having the workshops done, we have also built an error budget tool that calculates the SLOs. It's built internally, but we have seen lately that other companies also started outsourcing their error budget tooling. And in the end, we came to the conclusion that we cannot just support our first product, so we need to roll SRE to other products. So currently, we have more than 10 products that we oversee, and more than 150 services that we also oversee. That's pretty much it. We are at this point in the phase that having only one SRE team for the entire organization is not enough anymore, so we cannot handle more products than we already do. So we had to think about how to scale it. And the scaling model will be presented by André.
Thanks. Yeah, so we have 1 minute left. So as Alexandra said, we're currently thinking about how we can scale our SRE approach. We thought about different models. Two different aspects are pretty important to us. The number of supported teams from one SRE team or SRE engineer, and the proximity to the software delivery lifecycle. So the closer a site reliability engineer is to the software delivery lifecycle, the more powerful he can be or she can be. What we were talking about right now is the solution-independent X5 model. So we don't have domain knowledge about the tools that we support. It is very technical, it's very generic. We are now starting to think about trying out different models. So we try out X1, the embedded model, and X2, the embedded model plus a solution team. And that looks like this. So this is the embedded model. And the embedded model, we only have one site reliability engineer within one team. In this one team, he is completely responsible for make production engineering practices, helps the team to improve logging, monitoring, observability, is doing deployments and so on. But we already saw like a couple of benefits, but also drawbacks of this approach. Like the benefit obviously is that an SRE engineer is very close to the software delivery lifecycle, which makes him very powerful. Although, here coming back to our cloud infrastructure at our company is very generic and the engineers don't have much freedom to change it. So the site reliability engineer doesn't have a lot of work he can deal with. And there will be social pressure from the team, because if you are part of a team, you want to take part in team rituals, you want to work on the same things, and you don't always want to bother your developers with something else they should do except for the product work. So there is some social pressure. And finally, then it means there is not enough work for one SRE to only support one team. The second model is that we are rolling this out to one whole solution. In this case, you see like Shop. Shop has 4 teams. We have 1 SRE per team, so they take part in the rituals, but they also form a virtual team. We have a solution architect for this Shop system, and the solution architect finally managed this virtual team of SREs, and defines a backlog. They have a specific backlog of things they work on to make the solution production ready. And they are looking at the solution scope, so they are not looking only into one specific part of the solution, they are seeing the whole. And that has big benefit. The solution scope, they can much better, much more efficiently improve the stability of the whole solution. They're still very close to the software delivery lifecycle, but also we still have this social pressure within the team that the the engineers, the site reliability engineers are supposed or expected to also work on features. And finally, if we have 1 SRE in each team, it's also a big investment, and we currently don't see that we can keep them busy full time. But we keep trying the other models as well. And we didn't see that anybody so far solved this question. Every company does that in different ways, and I think there's not one way a company can do this. So, that's it. 2 minutes over time. I think we have to stop now. If you have questions later on, we will be at the Metro Systems Romania booth. You can ask us, and there will also the Metro Systems Romania coffee break, I think. So you will also find us there. Thanks for attending. Thanks for attending the quiz.
Thanks.